certain amount of angle has to be maintained for sliding to occur. And the second law says about coefficient of friction being independent on the apparent area, and third about on sliding velocity. These three laws are empirical, so not maintaining them doesn't violate natural rules and exception can arise. For this case, the coefficient of friction is constant irrespective of the load, and for this one, the coefficient decreases with increasing load. And for this one, the coefficient between copper surface is higher in value, but for chemical activity in air, copper oxide film generates here, of which the coefficient value is lower. But with increasing load, the film ruptures following this transitional line. Graph like this can also originate if there the coefficient friction uh, of the oxide film is higher than the metal one. There are three cases. For the diamond one, the coefficient is almost constant, and but for silicon and silica, after a critical load, the coefficient value increases because of plastic deformation and plowing, and also increases the wear particles with wear depth. So mechanism of friction. At the contacting point of those two surfaces, there's a bond generated, that is adhesion bond, and in the material itself, there is interatomic bond. If the adhesion bond is weaker, adhesion mechanism is followed where the asperities stays as before after sliding without rupture and plastic deformation. But if the adhesion bond is stronger, then deformation mechanism is followed where a part of the weaker material is ruptured with plastic deformation. These are the equation, this one for dry surface and this one for wet surface. Deformation mechanism can occur in two ways. At microscopic deformation, tip-to-tip contact is present, and this can rupture along this line or this line depending on the strength of the weaker material. And for macroscopic deformation, there's no tip-to-tip contact, but at larger area, and the harder material plows through the softer one, making grooves, and also with large volume deformation. Plowing. Plowing can contribute in friction. Plowing can increase wear particles like this with defined shape or kind of this irregular shape. And these particles in further can increase the subsequent friction and wear. So plowing depends on hardness, roughness of the surfaces, or also the particle size and their shape affect a lot. These particles can get trapped inside these asperities or can be gripped by the harder material, and further they can plow along while moving. And in by this case, they can further contribute in increasing the friction. So this was all. Thanks for your patience.
Thank you. 4 minute